In this lecture, we'll be looking at populations and how populations become samples of research studies. We will appreciate how samples are important in relation to quantitative and qualitative research, particularly quantitative research when we think about how the tradition of doing research via scientific methods. And we'll be looking at how probability is an important aspect of choosing samples, and we'll talk about different kinds of probability sampling and as well as non-probability sampling. We also have examples of what probability samples look like and what non-probability samples look like. We'll have a little discussion as well on adequate sample sizes too. So that's an overview of what we'll be talking about today. First of all, why do we create samples? So researchers create samples because we have to make the decision of who do we collect data from. Meaning to say, who are the participants, people that fill out the questionnaires or surveys that we send out, or people that we observe in the natural environments, or maybe the people that we interview. So those are people or participants involved in the research studies, and they are individuals as part of the sample. What do we collect from them, or what are the focus topics that we are collecting from them? Is it their views on, say, chocolate consumption? Is it how much they consume on a weekly basis, or how much money they spend, what they think about chocolate in terms of how chocolate makes them feel? So what is the focus? And for us, for researchers to have a good study and for us to determine who should be part of the sample, those are the questions that we have been talking about in previous studies or previous chapters about the research problem and the preliminary questions that frame the research agenda, or the things that we want to study, the phenomenon that we want. So first off, let's talk about population. So that's the first concept in this chapter. What is a population? A population is whereby all the things or the people in a community or a setting where all of them, every single one of them, possesses the same attributes or characteristics. So for example, let's say college students, just generically college students. So what is consistent among all college students? Well, they take classes at colleges. So there is this one characteristic or attribute that is consistent among all college students. So any population that we are thinking about, they must have that one common characteristic or ability or attribute or some definition or defining aspect of them that makes all of them part of this community. Okay, so that is population. What is sampling frame, our next concept? Sampling frame refers to things, to the available population that we can tap into. So you'll see that sampling frame will be a smaller set of population because sampling frame refers to the population or the individuals of things that we are able to tap into or are available to us. So back to my original example about college students. So if we talk about college students being the population in this example, the sampling frame will be UHD college students. You see that we're moving from college students to UHD college students. Okay, we're moving from everyone who is in college, who is studying in the college, down to a specific university because it's accessible. It's where we are presently. So because it's due to the availability of the students at this university, then the college students of this university is part of the sampling frame. Okay, and we condense it to a smaller unit, further still to a concept which we call a sample. Now we see a sample means it is a subset of a population, remembering that population is up here. So one example of sample will be, say, all of us who are students in this course. We are all college students. So up here, population, we are college students, but also belonging to a specific university that is available close proximity to us, and we are one course out of many courses offered and being taken at this university at this point. So we are a sample. You see that we're moving from every entity that's possible down to those that are available, and down to the selected few from the sample, therefore the subset of the population. Why are samples so important? Why do we spend so much time thinking or talking about samples? Because if a sample is representative, if it's representative of the population, then the researchers are able to make generalizations of their findings. Make those generalizations back to the population. What does that mean? It means that if the sample is representative of the population, meaning to say the individuals in that sample, they bear characteristics in similar proportions to the individuals in the population, then any study that has been done on that sample, which is representative, if the findings are statistically significant, then the researchers have the confidence to generalize those findings back to the population that they wanted to study. Right? So therefore, that makes the identification and the choosing of a sample for a research study very important. If the sample is not representative, then the researchers have a much more difficult time to convince his or her fellow researchers that the findings are significant and that they are important and generalizable back to the broader population that the researcher was studying. So we see that sampling and samples are important aspects of a research design, and despite everything that the researcher can control, or as much as the researcher is able to control, he or she will find that as the research process goes underway, and as he or she identifies the samples, there will be challenges, and we'll tackle some of these challenges later on in today's lecture. But more importantly, we want to look at how do we create, or how do we identify the most appropriate type of sample for each different research study. Previously, we looked at the importance of samples and sampling. Next, we talk about the dimensions or characteristics that are important or meaningful to the research study. And how do we know who is meaningful or appropriate for the research study? It depends on the hypothesis or the research question that the researcher sets out to investigate. Okay, so for instance, if I am going to study about how college students think about chocolate consumption, then the appropriate population will be college students, and eventually my sample has to have individuals who bear some characteristic of a college student, some operationalizable way of demonstrating that my sample, the people in my sample, are actually college students. So if they are not college students by the operationalized definition, then those individuals are not appropriate for my study, and so therefore they do not provide any kind of meaningful data to the hypothesis or research question that I want to study. Not that the study is useless, but it's just that it's not appropriate, it's not suitable. It does not help to understand or help me shed light on the hypothesis or research question about college students' chocolate consumption. So therefore, the sample must bear at least one common characteristic among themselves as well as the population that they come from. In choosing a sample, there should be some kind of procedure, whether it's a probability sample or a non-probability sample, so that to ensure that there is some uniformity in how we create or identify our sample. Especially for probability samples, it is very important that we ensure representative of the sample. Again, what does it mean to be representative? It means that the sample bears individual, or the individuals in that sample bears similar characteristics in similar proportions, more give or take, to the general population where they come from, meaning to say the population of interest. Representative samples, again, back to what we have talked about previously. If the sample is representative, then the findings or the conclusions that the researcher is able to make then can then be extended to the general population or generalizable to the population that the samples or the participants come from. Representative or probability sample means that the participants in those samples, they have equal or similar chance of being selected to participate. Representative samples also mean that we try to eliminate or reduce the chance of selection bias. What that means is that we want to eliminate the possibility of oversampling. What does that mean? So for instance, if I'm doing a study on students at a specific university, and suppose I want to have equal numbers of freshmen, sophomores, juniors, and seniors. So I want the same number of each of those 4 grades. Okay, if my sample is not representative, then it's likely that I have a way more number of, say, freshmen as compared to an almost equal number of all 4 grades. So that is one example of selection bias, where we oversample a specific subset of that population, and because of the overselection, it becomes not representative of the population of interest. And one great way to ensure representativeness is that we use random samples. And we'll take a look at what random sample means, as well as probability samples in general in the next couple slides. When we talk about probability samples, we want to ensure that the individuals or the units in that sample has a known chance, or they have equal chance to be selected. Okay, that means that when there is an equal probability of choosing those units or items or individuals, then it is truly random. So for example, let's say I have a jar. Okay, I have a jar, and in the jar I have golf balls of various colors. So I have red, I have green, I have blue. Okay, and let's say all the golf balls in there, between the red, blue, and green balls that I have in that jar, there is an equal number. There's an equal number of each of those 3 colors. Okay, so if the selection were to be truly random, that means that the subset of balls that I draw out of that jar, which is the sample, there should be more or less equal number of red, blue, and green balls that I select from the population. So when we are able to do that truly random style, then we are able to say that there is an equal chance that the items in that population will be drawn to be part of the sample, and therefore a random sample. Do note that sampling error will always occur because we are dealing with people in communication research, especially, and because researchers are humans too, and so researchers can make mistakes, even though we try our very best to minimize or to reduce the chance of mistakes. But we know error is always possible, and that can happen, and therefore sampling errors will always occur or happen, despite all the careful safeguards and procedures that the researcher takes to ensure that the sample is random. Here are a few different ways of doing probability sampling, and we can talk about them from the easiest to the more complex. Actually, they can be complex in different ways too, but in a way, there's some kind of simplicity in the earliest sampling method up here, right through to cluster sampling. So let's take a look at how they work. So a simple random sampling approach is the simplest and the quickest because it's truly random. There is no order, there is no system, there is no exact logic to it. It's just truly random. Okay, a jar of golf balls, I just stick my hand into it, I just, without looking at it, without looking at it or feeling for a specific texture or feel, I just randomly pull out one and then pull out a few more from the jar, and so that's random. Okay, truly random. There's no real logic, there is no real order or specific system. It's just random. Okay, so everyone who is in a population in the sampling frame would have equal opportunity, equal chance to be selected. Okay, truly random. Next, systematic sampling. What that means is that we're increasing some order of predictability as well as some kind of system. Okay, we're adding some kind of order to it. It means that we are choosing systematically a sample or systematically choosing an item based on some order. So for example, say every fifth student on a list that I have, okay, every fifth student on the list that I have will be invited to a study. So every fifth student, the fifth, the 10th, the 15th, and so forth, so on and so forth, every fifth student will be invited. So you see there is some kind of order. Okay, so that is not like the first one where it's truly random, there's no order, there's no system. Systematic sampling, there is some kind of order, there's some kind of logic. So the example I gave you, every fifth student, so there's some kind of logic to it. Stratified random sampling means that we're trying to establish more or less a similar number of participants from a larger sample. So for instance, say students at a university. Let's say I want to have the same number of freshmen, sophomore, junior, and seniors in my sample. So what I would do firstly is to identify all the students at the university, have all the freshmen in this category in the first group, have all the sophomores in the second group, all juniors in my third group, and all seniors in my fourth group. Now that I have four groups, freshmen through seniors, then from each group I will draw randomly individuals from each of this group. So what stratified random sampling looks like is that we first categorize the participants, put them in the groups that I want to draw from, and then after I've created those groups, I use the simple random sampling for each of those groups. So the idea is that if I have my four groups well defined and established for my study on university students, and then I randomly choose, say, 50 freshmen, 50 sophomores, 50 juniors, and 50 seniors, then I should get a sample, a rather well-established probability sample of 50 students from each of those four grades. Now let's talk about cluster sampling. Cluster sampling is different from the earlier three types of sampling that we have discussed. Reason because cluster sampling is done when we do not know the complete number of the people of that population. Okay, so for instance, if we're talking about students, university students at University X, for instance, it is quite easy to establish that maximum or the complete number of students at the university, because I can go to the registrar's office and ask what is the number of students at the university at, right now, at present. So the registrar's office is able to tell me a number. So that number is the complete number of students at that university. On the other hand, there are some attributes or perhaps some populations where we do not know the complete number. So for instance, I might say college students who love chocolates. Okay, so I don't know if there is some kind of club or some kind of interest group out there that where college students who love chocolate, they are members of. So without that kind of tally, without that kind of organization where all college students who love chocolate are members of, then I do not know the complete number. Okay, because I do not have that complete number, then I can only apply cluster sampling, because the complete number of the participants who share the same attribute or characteristic is not known. And because of that, complete list of the population is not known, we will then apply the cluster sampling approach. We have talked about probability sampling quite a little bit in the previous slides. So now we transition to non-probability samples or sampling. In non-probability samples, then we do not rely on any random selection techniques as we discussed in the previous slide. There is no randomness or representativeness to talk about in non-probability samples. Therefore, it's weaker in that sense in relation to probability samples, because non-probability samples are not representative of the population. So there's a downside there, there's a disadvantage of non-probability samples. We would, however, in certain instances, may actually prefer to use non-probability samples because it allows us to tap into specific communities that would not be accessible or is not practical using probability samples. Okay. And then that is especially so when we desire or we want to create a sample based on a very specific type of experience or abilities of the participants. For example, if I am conducting a study on, say, Vietnam War veterans, it will not be useful to use probability sampling. For example, say I go visit the entire city and then visit every other house and say, "Hi, I'm doing a study on Vietnam War veterans. Can I speak to one of them in your house?" Chances are they might not be all living in the same neighborhood. So therefore, probability sampling for Vietnam War vets, especially if I'm trying to find them in just any random city, is not a good approach. Instead, we'll use non-probability sampling if that's my interest. So perhaps I might know Vietnam War vet. Actually, I have a neighbor who is a Vietnam War vet. Then I might approach him and see if he is interested to participate in my research, and if so, or whether or not he is interested or not, I might ask him, could you introduce other Vietnam War vets to my study, and then I hope to conduct a study on them because they share a specific, unique, special experience that I'm trying to reach out to. Okay, so non-probability samples, even though they are not representative, they also serve a unique and useful purpose when we do research. Here are examples of non-probability samples. First off, convenience sample, probably the most common type of sample used. Convenience samples are samples that are easily accessible to the researchers. So if a researcher is doing a study on college students, then naturally the college students who is around him or her will be the natural choice. Volunteer sample is similar to convenience sample. Only difference is that volunteer sample will be participants who volunteer. For example, I might say put up notice on a notice board saying I'm doing a study on college students about their chocolate consumption. So one day someone walks by, sees the notice, and then volunteers and say, I want to be part of the study. So if that was the case, that will be a volunteer sample. Again, if that is the way that I recruit my participants. Snowball or network sample means that participants introduce other individuals who have similar characteristics to the researcher. So the example I used in the previous slide about Vietnam War vets, my neighbor who is a Vietnam War vet may tell me, hey, here are 5 of my buddies, you can contact them, or I can ask them to give you a call. So that will be a snowball sample. Inclusion and exclusion sample, what that means is that what is the characteristics that the researcher wants in the sample and what will be excluded. If I'm doing a study on college students, again, I might say college students, what it means is that they have to be, say, taking one course at the very least this semester. I might add other inclusion criteria if it's appropriate or necessary for a study. So if I'm studying students who are more or less in the traditional age bracket, then I would say as well that the participants have to be, say, between 18 and 25 years old. Okay. But if, say, I'm doing a study on non-traditional college students, I might say the student or the potential participant has to be above a certain age, say 25 or 30, some number, something that I can justify to explain why I include or exclude certain individuals to be part of my sample. Purposeful sample means that the researcher purposefully pursue individuals with that specific characteristic. So for example, back again to the Vietnam vet example, I would specifically look for individuals who served in the military during Vietnam War. Someone else who served in the military but fought in other wars or were not during that time during Vietnam War, then no, that would not work because the purpose of the research was to study Vietnam vets, and so I will pursue a purposeful sample that is specifically targeted to the characteristic that I'm looking for. Quota sample means that the researcher sets out with a fixed number in mind, say 25 or 50, whatever that number is. So the researcher, once he or she hits that number that he or she sets out to collect or to interview or to reach out to, once that number of participants is reached, then the researcher says, okay, that no need to recruit any more participants because I've met the quota, I've met the number of participants that I want to be part of this study. So here we have 6 examples of how non-probability samplings techniques could be applied and the corresponding names for those types of samples. Sample size can usually be predetermined, especially for quantitative research. So quantitative researchers would usually set out with a number or a threshold number that they have in mind. They would like to meet that number, and of course, more is usually better. So they will try to hit at least that minimum number that they want to collect their sample from, or rather the data from. But of course, if they can manage to collect even more, that will be better. You'll see in the textbook page 102 table 6.1 that gives us a table that shows us that depending on the population size, a researcher might want to choose the corresponding sample size so that the researcher can establish a 95% confidence level. So don't worry about that number just yet, the 95% confidence level or the 5% sampling error. We'll spend time talking about that in the future chapter, but know that in quantitative research especially, if we know what the population size is, then there is a corresponding sample size that we would desire to reach or to attain so that the sample is adequate for the researcher to work on. There is no need to memorize these numbers in this table because these tables are easily accessible, but do know that there is some models or some numbers like these that are available for researchers to determine what would be a good sample size. And these numbers are determined prior to them actually collecting the data before they select the sample. The sample size will almost always be a smaller number than the number of people that you ask to participate. You might ask 100 people to participate, but some of them might say not interested, or they might not follow up or follow through with what they promised to do, or they just didn't show up, or various reasons. So we got to ask more people to be part of the research, but in reality, most situations the sample size will end up to be a little smaller or much smaller depending on the sampling technique that you use. The larger the sample that we are able to get, theoretically there will be less error or bias in it because we are sampling more people, a greater number of people than is minimally needed for us to do the study. So this research approach is good. So if we have, say, looking back at table 6.1, if we have a population of 260 individuals, we should at the minimum be able to have a sample size of 155 people. But if we have more than 155, that's great. The more we can get, the better it is. But of course, we have to be cognizant that in terms of resource and time, we might not want to go all the way to like say 5,000. Okay, that's pretty excessive. Okay, because 5,000 is not possible if the population is only 260. But the reason why we have a certain number to hit is that we want to have that confidence level to say that the findings of the sample is adequate for us to generalize to the population of interest. So then we have in today's class, we talk about populations, how do we boil it down to sampling frame and eventually the sample that we can draw from, what is probability sampling and what is non-probability sampling, examples from each of those, and how do we determine sample size. And that is the essence and the most important aspects of this chapter.